So in this ACT math video, we're going to take a look at quadratic equations, or polynomial equations where the highest power is x squared. And we want to know that out of these answer choices, which quadratic equation has real irrational solutions. So at this point, you can stop the video and try to solve it on your own, or you can keep going and we'll work into getting this solution. So with quadratic equations, as I've said before, the highest power is x squared. And there's different types of solutions you can expect when you deal with these types of equations. So the first type of solution you can get are what I call normal solutions. They're the normal numbers that you're used to dealing with: fractions, whole numbers, and integers. You can also have what we call irrational solutions. An irrational number is a number that goes on forever as a decimal, but never in any particular pattern. And the most common irrational numbers we deal with on the ACT are imperfect square roots. And so I've shown two examples here. So the type of solutions that you'll get from a quadratic equation would be for something like, for example, 1 plus or minus square root of 2, or -3 plus or minus root 7. Now you can also get imaginary or non-real solutions. So for example, the square root of 25 is equal to 5 because 5 times 5 gives you 25. Now looking at the square root of -25, this one won't work because there's no number you can multiply by itself that will ever give you -25. So we can't take the square root of a negative number. So we have to give it a special designation by calling it imaginary. So whereas the square root of 25 is equal to 5, the square root of -25 is equal to 5, but imaginary. And so some of the type of non-real solutions we can expect from a quadratic equation would be examples like 4 plus or minus 5i, or -7 plus or minus root 6i. Now notice that root 6 is an imperfect square root. So you can actually have non-real solutions that have irrational roots in them. And so that's why in our problem, we're going to focus on irrational solutions that are real and not imaginary. So to solve this problem, we're going to take two different approaches. The first approach we're going to use is we're going to solve each one of these equations until we find the first one that has real irrational solutions. The second approach we're going to use is we're going to use the discriminant to quickly cancel answer choices until we find the answer that has real irrational roots. So let's go ahead and solve this first equation. So the first way I can solve this equation is using square roots. And so I can start off by bringing the 16 to the other side. You're going to end up with x squared is equal to 16. And I can cancel out the power of 2 by taking the square root of both sides. And when you take the square root of both sides, just make sure you do plus or minus. And so x is going to equal plus or minus 4. Okay. Now the second way you could have solved this is you also could have used factoring to solve this. X squared minus 16 is what we call a difference of two squares. It can be factored as x minus 4, x plus 4. And now we have to find out what numbers will make each piece equal to 0. Some people can look at this equation and tell what numbers will make it equal to 0. If you're not sure, just set each piece equal to 0 and solve each equation. So for the first one, I'm going to have to add 4. So that gives us the first solution of x equals 4. Solving the second equation, you're going to end up with x equals -4. So once again, you're going to have x is equaling plus or minus 4. This is clearly not irrational, so we know the first answer is wrong. Looking at the next equation, this one can also be solved by factoring. So we have x squared minus 8x plus 16. I need two numbers that are going to multiply to the last number and add up to the middle number. And so I'm going to end up with, so to make x squared, I'm going to need x and x. And the two numbers that will multiply to 16, that will give me an 8, will be 4 and 4. They have to add up to -8. So I'm pretty sure -4 plus -4 gives you -8. So now we just have to find out what number will make this equation equal to 0. Since both pieces are the same, I only need to solve one of the pieces. Adding 4 to both sides. You're going to end up with x is equaling 4. 4 is definitely not an irrational number, so we know this one is also wrong. So this equation can also be solved two different ways. The most common way to solve it is using square roots. X squared plus 16 is equal to 0. I can subtract 16 on both sides. This is going to give me x squared equals -16. And I can cancel out that power of 2 by taking the square root of both sides. We can't take the square root of a negative number, so we know this is going to end up being imaginary. Square root of 16 is equal to 4, so this is going to end up being 4i. So clearly we need real solutions, not imaginary ones. So we already know this choice is going to be wrong, but I'm going to go ahead and show you the second way to do it. Not everybody knows how to do it this way, and if you don't, that's perfectly okay. As long as you know how to solve it by square roots, that's perfectly fine. You can also factor this using imaginary numbers. X squared plus 16 actually factors into x plus 4i, x minus 4i. And I'm going to go ahead and figure out what numbers will make each piece equal to 0. I can subtract 4i on both sides on this one. So x is going to equal -4i. For the other equation, I can add 4i to both sides. X is equaling positive 4i. So once again, x is equal to positive or -4i. These are not real solutions, they're imaginary. So once again, this is wrong as well. Now let's look at this equation. First thing I'm going to do is I'm going to try to factor it. X squared plus 3x plus 4. That means I need two numbers that multiply to positive 4 and add up to positive 3. So to get x squared, I need x and x. And to add up to 3, well, to multiply to 4, we can use 4 and 1. And to add up to 3, we can use positive 4 and minus 1. Because 4 plus -1 definitely gives us 3. The only problem with this is 4 times -1 gives us -4. It doesn't multiply to positive 4. So this doesn't work. Let's try another one. Let's try this again. We can do x and x. And let's try 4 and 1 again. And let's make them both positive. So now they will definitely multiply to positive 4. But then 4 plus 1 is 5. It doesn't add up to 3. So this is wrong too. So this is not factorable. So we're going to have to employ another technique in order to solve this equation. So when a quadratic equation can't be factored, you can use a special formula called the quadratic formula to get the solutions. Now you have to make sure that it's in the form ax squared plus bx plus c equals 0, where a is the number that's with the x squared, b is the coefficient or the number that's with the x, and c is the constant or the number that's on its own. And the formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And since our equation couldn't be factored, we're going to go back and use the quadratic formula for it. So now we're going to solve this equation using the quadratic formula. So x squared plus 3x plus 4 equals 0. A is equal to 1, B is equal to 3, C is equal to 4. Using the quadratic formula, it's going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Working that out, you're going to end up with negative 3 plus or minus the square root of 9 minus 16 all over 2. This is going to be negative 3 plus or minus the square root of negative 7 over 2. We're taking the square root of a negative number, so we know this is going to end up being imaginary. So this is going to be negative 3 plus or minus the square root of 7i over 2. So even though the square root of 7 is an imperfect square root, it is irrational, but we want real irrational solutions, not imaginary ones. So now we know this one's wrong. So now let's look at the last equation. So obviously, if the first 4 are wrong, then it's obvious that the last answer choice is going to be the right one. But I'm still going to work it out. Okay? So first thing I'm going to check for is to see if it can be factored. Let me turn on my pen. You should always try to factor first, since factoring is much faster than using the quadratic formula. So if I try to factor this thing, I'm going to end up with x and x. It needs to multiply to negative 3, add up to 4. I can possibly use 1 and 3. We need to add up to 4. So positive 1 and positive 3 definitely add up to 4, but they don't multiply to negative 3. So I know this one's wrong. How about we try this one? X and x. Now keep in mind on your test, all of this is going to be moving a lot faster. I'm moving very slow to kind of teach and to kind of show you the techniques at the same time. But obviously, when you're against the clock, you're going to be moving a lot faster than this. So let's try to make negative 3 out of it. So I'm going to do 1 and 3. And we can do a negative 3 times a positive 1. That definitely multiplies to negative 3, but it doesn't add up to 4. So we can see that this is not factorable. We're going to have to use the quadratic formula again. So now let's use the quadratic formula. So we have x squared plus 4x minus 3. A is 1, B is 4, C is negative 3. So we're going to have x is equaling negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Working this out, you're going to end up with negative 4 plus or minus 16. Negative 4 times 1 times negative 3 makes a positive 12 over 2, which then gives you negative 4 plus or minus the square root of 28 over 2. This is an imperfect square root, and even if you simplify it, it's still going to be imperfect. For example, if you do 28, square root of 28 is the square root of 4 times the square root of 7. And so that simplifies into 2 root 7. So either way, it's going to end up irrational since it's an imperfect square root, and it's also real. So it's real and irrational. So we know that this is the correct equation. The answer is E. Now, the second way to solve this problem is to use an expression called the discriminant. It's actually the expression that's inside of the square root when you do the quadratic formula. It's equal to b squared minus 4ac. And it tells you the type of solutions you can expect. If it comes out negative, you're going to have two non-real or imaginary solutions. If it comes out equal to 0, you're going to have one real solution. And if it comes out positive, you're going to end up with two real solutions. Now, for our equation, we're going to put a slight twist on it. And the key thing to understand is that whatever that discriminant comes out to be, that's what that square root is going to come out to be when you do the quadratic formula. And so we're going to use this to quickly eliminate answer choices and figure out the equation that has real irrational solutions. Let's go ahead and get the discriminant for these equations. So we're going to have with the first one, 1x squared plus 0x minus 16 equals 0. Since there's no x term, we placehold it with a 0. And so a is going to equal 1, b is going to equal 0, c is going to equal negative 16. And so the discriminant is going to be b squared minus 4 times a times c. That's going to give us 0 plus 64, which is 64. That means in the quadratic formula, I'm going to end up with the square root of 64. This is a perfect square root, so we know this can't be the right answer. Working with the second choice, x squared minus 8x plus 16 equals 0, where a is equaling 1, b is equaling negative 8, c is equaling 16. You're going to end up with b squared minus 4 times a times c. That means you're going to end up with 64 minus 64, which is 0. That means in the quadratic formula, I'm going to end up with the square root of 0. That's also not irrational. That's a perfect square root. Also wrong. Let's look at the next one. Like I said, I'm trying to look for the one that's going to give me real irrational solutions. So this is going to be 1x squared plus 0x plus 16 equals 0, where a is equaling 1, b is equaling 0, c is equaling 16. And so the discriminant is going to end up being 0 squared minus 4 times a times c. That's going to give me 0 minus 64. That's negative 64. So inside the quadratic formula, you're going to end up with the square root of negative 64. We know that's going to be imaginary. It's not real. So we also know this is wrong. So let's go ahead and check out the last two answers. Now let's get these last two discriminants. So this is going to be 1x squared plus 3x plus 4 equaling 0, where a is equaling 1, b is equal to 3, c is equaling 4. So the discriminant is going to be b squared minus 4 times a times c. That's going to be 9 minus 16, which is negative 7. So I know in the quadratic formula, we're going to end up with the square root of negative 7. We already know this is imaginary. It's not real, so we know this one is wrong as well. Let's go ahead and work out this last one. Where a is going to equal 1, b is going to equal 4, c is going to equal negative 3. So you're going to end up with the discriminant of b squared minus 4 times a times c. And this is going to end up giving you 16 plus 12, which is 28. So I know inside the quadratic formula, it's going to give me the square root of 28. Not only is this irrational because it's an imperfect square root, it's also real. So once again, the answer is E. So as you can probably tell, choosing the quadratic formula can take up a lot of time. This is why you should always try factoring before you try the quadratic formula. So if you're not great with factoring, I suggest you get really good at it. And the great thing is, these are just tools. So that means you can use a combination of factoring to eliminate answer choices And then with the answer choices left over, you can possibly use the quadratic formula or the discriminant to figure out which choice is the right choice. These are just simply tools to help you figure out the right answer quickly. And so if you ever want to know about the number of solutions or the type of solutions you're going to have, you can always use the discriminant to describe those solutions. Go ahead and take a visit to mathonthefly.com, where we have over 100 ACT math worksheets that cover a variety of topics. And while you're there, go ahead and join our mailing list. Why not? You can get good updates on what's going on. And we also have our ACT math book that has over 1,100 problems with complete solutions and the perfect guide for the test. With that being said, I hope you liked the video, and I'll see you in the next video.